Alright, hello everyone, welcome to this video. So today we are going to be covering the October-November session 2002 Mathematics D paper 2. So the paper 2s usually have a calculator allowed. There are 100 marks. You're expected to use a calculator, and if the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures given in degrees to 1 decimal place. So that's all we need to know. And usually, because the calculator is allowed in this paper, it's more about knowing how to solve the problems rather than the actual solving of the problems, because you can kind of use the calculator to help you out there. Okay, so let's get started with question number 1. So the question says the diagram I shows a path AC in park ABCD. So the path AC in a park ABCD. It is given that AC is equal to 530 meters, BC is equal to 370 meters, and AC is perpendicular to BC. So AC is perpendicular to BC. That just tells us that there is a 90-degree angle right there. Calculate the angle ABC. So they want us to calculate this angle. So one thing you should be aware of, if you aren't, is these three numbers, or not numbers, but these three shortenings. So this is so, ca, toa, which basically gives us, so these three stand for sine, cosine, and tan, and it tells us what equation sort of gives us the tan or the sine or the cosine of this angle right here. So what this is basically saying, that the sine of an angle theta is going to be equal to the opposite of that angle on top of the hypotenuse of that angle. So the first letter denotes what's up here, and the second letter denotes what's down here. So in that way, the cosine of an angle is going to give us the adjacent. So this one's adjacent, this is opposite, and this is hypotenuse. It depends on the angle. If we were calculating this angle, the opposite of this angle is that, the adjacent is that, and that is still hypotenuse. So anyway, what do we really have for this angle that we want to calculate? And let's call this angle theta. So we have the opposite and we have the adjacent, right? We don't have the hypotenuse. So what we can figure out is that tan of theta is going to be equal to the opposite, which is 530, over the adjacent, which is 370, right? And then in order to get rid of tan, which is a function, use the inverse of that function to basically get theta here, and then we can inverse the function on the opposite side to actually get the value of theta. Let me actually use my calculator to inverse the function on the opposite side. So theta will be equal to the tan inverse of 530 over 370, which means it will be equal to 55.08, or if we convert that into 3 significant figures, that would be 55.1, and our answer is going to be 55.1 degrees. All right, let's move on to the second part. Part B says, diagram 2 shows two other paths. Diagram 2, this one, shows two other paths, AE and CE, in the park. So AE and CE. Given that CAE is equal to 25 and AEC is equal to 90, calculate the length of AE. All right, so we need to get the length of AE. The first thing we can actually do is figure out this angle. Since we have our 90 and we have our 25, that adds up to 115, right? And all the sum of the internal angles in a triangle is 180, so I just subtract that from 180, we get a 65. Get a 65. All right, so we know this angle is 65. So there is another law called the sine law, which basically tells us that the ratio of the opposite angle, of the opposite length, and the sine of this angle, so in this case, this would be AE over sine of 65, is equal to the ratio of the sine of this and the length of that. So this would be equal to 530 over sine 90, right? And sine 90 is equal to 1, so I can just get rid of that. So AE is just going to be 530 sine of 65. And again, I can use my calculator to quickly do that. So let's do 530 sine of 65, right? And we get 480.3, or we can simply say 480. So 480 meters is the answer for part B. All right. Now, given also that ACD equals 70 degrees and CAD equals 90 degrees, calculate first the length of CD. So ACD equals 70 degrees and CAD equals 90 degrees. So again, the first thing we can do is just get this part. So let me move back up here. So to get that angle, again, we have our 90 and we have our 70, which gives us 160. We can minus that from 180 to get a 20. And so this angle is 20. And then now we can use the same rule that we just used to figure out CD. So CD over sine of 90, since this is the opposite of CD, is going to be equal to 530 over the sine of 20. Now sine 90 is equal to 1, so we can just get rid of that, and let's do 530 over the sine of 20. That gives us 1549, or we can just do 1550. So the first part of this is 1550 meters, and now we need to find the area of part A, B, C, D. So the area of the entire park, now I can do this by calculating the area of the two triangles. I can also figure out that this is a trapezoid, and we know how to get the area of a trapezoid as well. If you don't know what the area of a trapezoid is, it is half into the base, or the height, which is basically the distance between the two parallel lines, and then into the sum of the parallel sides. So what that entails for us is, well, first of all, we need to find AD, and we can find AD similarly to how we found CD. So to find AD, we would do AD over, what is the opposite of AD? 70. So AD over sine 70. Sine 70 is equal to 530, since we know that, over sine 20, right? And luckily, my calculator already has 530 over sine 20, so I can just multiply that by sine of 70, and that gives us 1456.16, but I'll just take 1456.2 just to be sure. So 1456.2. All right, now we know our two parallel sides, and we know the distance between the two parallel sides, which is just going to be this space, and we already know this to be 530. So you can do half of the base, which is 530, into the sum of 370 plus 1456.2. And again, I could just use my calculator, and let me write exactly what I've written there into my calculator. So 530 into the sum of 370 plus 1456.2, and that is 483943, or we can just do 484000 in 3 significant figures. So that would be 484,000, and that is question 1. One thing I also forgot to add here is that this is an area, so it is 44,000 meters squared. Anyways, let's do question number 2. So question number 2 is solve the equation x minus 5 squared. Well, part A is x minus 5 squared is equal to 81. So this is a pretty simple question. Let me do it on this side. So let's do x minus 5 squared is equal to 81. So we could expand this, or we could simply get the square root of both sides, since I know 81 is a perfect square. So that would give me x minus 5 is equal to, well, the square root of 81 is 9, but it's also negative 9. So now we have 2 possible answers for x. So the first answer for x would be if I add 5 to both sides with 9. So if I add 5 here, 5 disappears here. If I add 5 here, x is equal to 14. And for the opposite end, if I add 5 to negative 9, x is equal to negative 4. So 14 and negative 4 is the 2 values of x. I'm just gonna draw a square around these to say this is the answer for A. Alright, so we have expressed as a single fraction in its simplest form a over 2a minus 1 and a plus 1. Alright, so a over 2a minus 1 minus 2 over a plus 1. So the first thing that we simply need to do is we need to multiply this side by a plus 1 and this side by 2a minus 1, right? And then that is on top of these two being multiplied by each other. And I'm not simplifying this, because even if I simplify it, if I refactorize it, I'll come back to here. So I do not want to simplify that right now, but let's simplify the top part. So we get a squared plus a minus 2 into 2 is, so minus 4a, and then minus minus would be a plus, so plus 2, right? And then let's simplify that further. We got a squared, 1 minus 4 is minus 3, minus 3a plus 2. So one thing that we can do here is something called breaking the middle term. And when we break the middle term, we basically want something that is that 2 numbers that are going to add up to this middle term, and that's why we're breaking the middle term into 2 numbers. It's going to be able to make it easy for us to factorize this equation, but also these 2 numbers should be able to multiply with each other to make this number. So there's quite a few methods on this, and I'll probably make a video of it, like a method to do it. But for this, we don't really need to think that much, because we can just break it into minus 2 and minus 1. If we multiply minus 2 and minus 1, we get 2. If we add them together, we get 3. We get minus 3. So that fits it perfectly. It makes 2 when multiplied, and it makes 3 when, or minus 3 when added. So we can simply do a squared minus 2a minus a plus 2, right? So now what we can do from here, now we can factorize it pretty easily. We can just take a common from here. So we get a minus 2, and then we can take minus 1 common from here, get a minus 2. And so we have our factorized form, which is a minus 1 and a minus 2. And now we can throw that back into the entire thing, and we have a minus 1, a minus 2 over 2a minus 1 and a plus 1. And I don't think I can make it simpler than this. These, I mean, obviously we can expand these, but we can also leave it like this. And I think this is its simplest form. So there we go. All right, in that last part, we have given that a is equal to h, so a is equal to h for m plus h we need to express m in terms of, so we just need to make m the subject of this. So the first thing I can do is divide both sides by h, so we get a over h, and then if I divide this side by h gets removed, so we are left with 4m plus h. All right, now we can subtract h from both sides, so ah minus h is equal to 4m. All right, so far so good. And now all we can do is multiply both sides by 1 over 4. So if I multiply this by 1 over 4, it's just going to get rid of the 4 here. And then this side, let's do that. So a over 4h minus h over 4, right, is equal to m. And then we can simplify this side a bit. We know that we just need to make this denominator into it. So we can multiply this side by h over h, which is basically 1, h over h is 1, to make the denominator equal, and then we can just simplify it a little. So that would make a minus h squared over 4h, and that is equal to m. And I don't think we can do anything else. We've already made m the subject, so there we have it. M expressed in terms of a and h would be a minus h squared over 4h. Moving on to question 3. The points A, B are minus 2 and 1, and 6 and minus 5 respectively. The gradient, and we need to calculate, well, in part A, or in part 1, the gradient of line AB. So the line between these 2 points. So to get a gradient between 2 points, all we do is y2 minus y1 over x2 minus x1, and y2, we'll just assume this is y2 and x2, and this is x1 and y1. You can obviously do the opposite as well, and you'll still get the same gradient. But anyways, let's do minus 5 minus 1 and 6 minus 2. All right, so minus 5 minus 1 is minus 6, and minus 6 minus 2 is basically 6 plus 2, so that would be 8, and this becomes 3 over 4, or minus 3 over 4. So gradient of line AB is minus 3 over 4. All right, part 2 is equation of the line through A and B. So all we need to do is now take this gradient and make an equation out of it. So the equation of any straight line is y is equal to mx plus c, where m is the gradient and c is the y-intercept. So we know m, we just don't know c. So let's take one of the points, let's just take that one. So minus 5 is equal to minus 3 over 4, and then the x is 6 plus c. And now we can just simplify this to get, to get the value of c. So first I'm just gonna basically multiply both sides by 4. So that would leave us with 4 5s are minus 20, and this would be minus 3 into minus 6. We can just do, or minus 3 into 6 is minus 18 over 4, and then plus 4c, since we're multiplying the whole thing by 4. Wait a minute. Okay, so first thing we can do is basically get rid of this denominator by multiplying this side by 4 and multiplying c by 4, so that we can basically get rid of the denominator. So first I'm just gonna do this. So 3 into 6 is actually 18, so why don't I just write minus 18 plus 4c over 4. And then now if I multiply both sides by 4, I get minus 20 is equal to minus 18 plus 4c. And now I can add 18 to both sides. So if I add 18 here, I get minus 2, and if I add 18 here, I get a 0. So minus 2 is equal to 4c, which means c is equal to minus 2 over 4, or minus 1 over 2. So our equation would then be y is equal to minus 3 over 4 x minus 1 over 2. And we can even simplify this further, although I doubt they need you to. But we can realize that this is the same as 2 over 4 minus 2 over 4. So what we can do is we can do minus 3x minus 2 over 4, and then 4y is equal to minus 3x minus 2. Now you could have left it like this, right? That would have been a fine answer. Or you could simplify it into this, which is still the same answer. Okay, so let's move on to part B. The points C and D are 4, 4, and 5, and P and Q, respectively. So C is 4, 5, and D is PQ. Write down in terms of PQ the coordinates of the midpoint of CD. So there is a point C, and there is a point D, and C is 4, 5, and D is PQ. So what we want is the midpoint, so 4 plus P, and then the midpoint would be halfway between these, and let me get rid of that, and then the second part would be 5 plus Q, and the midpoint would be halfway between these. So this is part 1. This is part 1, and then part 2 asks us, given that the midpoint of CD is 7 and 1, find the coordinates of D. So all we simply need to do is first find P, which is this is equal to 7, which means 4 plus P is equal to 14 after multiplying both sides by 2, and P is equal to 10. All right, we can do the same thing on this side. 5 plus Q is equal to 2 is, 5 plus Q over 2 is equal to 1. 5 plus Q is equal to 2, and then Q is equal to negative 3, because I'm dividing, first I'm multiplying both sides by 2, and then I'm subtracting 5 from both sides. So 5 gets subtracted from here, and 5 gets subtracted from here, which leaves us with a minus 3. So D is 10 and minus 3. And I think that's us done with that question. Let's move on to the second question. Okay, let's do question number 4. So in the diagram, ABFG is a rectangle. So ABFG, this is a rectangle, which means that these two are equal and these two are equal. And BCDE is a square, which means these two are equal, and basically all 4 sides are equal. All right. So ACG and GFE are straight lines. So GFE, so basically this extends there and it's a straight line. And ACG, so again, this is a straight line as well. All right, show that the angle ABC, so this angle is equal to FBE, this angle. So how we do that is, well, first, let's just call this angle theta so we can refer to it. Now, we know that this is a square, so it'll be a right angle here. It'll be 90. So if I just want to get this part, what I would do is I would minus theta from 90. So just this part would be 90 minus theta. And now, if I come back here, let me just actually erase all of that. So just this part is 90 minus theta. And then if I wanted to get this part, this is also a right angle, as we know. So this part would just be 90, which is the right angle of that square, minus this part which we just got, which is 90 minus theta. And then the 90 and the 90 would cancel out, and the minus minus would make a plus, so it would just be theta. So both of these parts are theta, which means that it is proved, right, or shown. All right, part B, show that triangle ABC is congruent to triangle FBE. So there's 3 ways that you can usually show if a triangle is congruent. Congruent basically means that both of the triangles are the same triangle. So the first way is you can show that the 3 sides are the same. The second way you can show is there are 2 sides that are the same, and the angle between those sides is the same. So 2 sides are the same, and an angle between those sides is the same. And the third way that you can show it is that 2 angles are the same, and then the side in between those angles is the same. So it's side, angle, side, 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 or angle, side, angle. So I think the easiest part would be this one, side, angle, side, since we know that we have a theta and a theta right here. So let me just do this down here. So we know that this part and this part is the same. So this side and this side is the same. Actually, probably what we can do also is actually show angle, side, angle. So the side in between two angles is going to be the same. And that one might be a little bit easier to show right now. So this side and this side are the same, and the two angles on the opposite side of that is now what we need to show. So we already know that. So first thing what we can do is we already know that ABC, so angle ABC is equal to angle FBE, right? FBE. So we have the first angle, which is the same. Then we also know that BC, which is a side, is equal to BE. Is equal to BE. So the first angle is the same, second side is the same, and now, I mean, we have this 90 as well. We have this 90 and this 90, but we also can see that if this is theta and this is 90, then this would be 90 plus theta. This would be 90 plus theta, and then 180 minus that, right? 180. My 8 is very weird today. Let me try that again. So this would be 180 minus 90 plus theta is what this angle would be, and it would be the same here. So we can also show that angle ACB, so angle ACB is equal to 180 minus 90 plus theta, right? And the same goes for angle FEB or BEF. And angle BEF is also equal to 180 minus 90 plus theta. Hence, ACB is equal to BEF. Let's wrote BE, so B. BEF, and therefore the triangles are congruent. Therefore, for the triangles are congruent through angle, side, angle, angle, side, angle. We showed the first angle being equal, we showed the side being equal, and then we showed the angle on the opposite end of that side also being equal. So that is done, and now part C says, hence show that ABFG is a square. So let me just make space for part C. So since so because both of these triangles are congruent, right? And both of these triangles, so let me just draw them out like this. So one of them is like this, and the other one is like this. And we know that this side and this side are the same. And obviously, since they're congruent, all of the sides need to be the same. But if we look at our demarcations here, so let me just mark that in red. We look at our demarcations here, right? We know that we marked this bit with a 2 since it was one side of the rectangle. We marked this bit with a 1 since it was a different side of the rectangle, and it said that it's a rectangle, so we thought they would be of different lengths. But if the triangles are the same, it means both of these sides need to be the same. So AB needs to be equal to BF since they are congruent. And if both of these sides are equal and they are the two sides of the rectangle, that would mean that the rectangle is actually a square. So since AB is equal to BF, ABFG has equal sides and is therefore a square. I think that's roughly all you would need to say, but obviously this could be said in a much shorter or even a much longer way, as long as like you're covering like y. So since AB is equal to BF, ABFG has all equal sides, and therefore it is a square. I think that's the main part, that you need to identify that these two are equal, all of those are equal, and these two are two different sides. So that makes it a square. All right. It's time for question number 5. In the diagram, A is the point 110, 10, 1, and AB, the vector AB, and vectors are directions, so this would be the direction. So AB is minus 8, 15. What this is basically telling us, that you go minus 8 in the x direction and 15 in the y direction to get from A to B. So what they need us to do, firstly, is to find the distance between A and B. This just demarcates that, especially in vectors, essentially, but this works with like almost all mathematics. If you have the absolute value like this, it just basically means they want you to find the difference or the distance between whatever's in between whatever's in there. So this is the distance AB is what they want us to find. So what this has already told us is, let me get that correctly. So bloop, 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 and bloop, bloop, bloop from here. So we know that we go up 15 and this is a minus 8. But since it's actually like a distance, it'll obviously be positive. So we have a triangle here. And if we want to find this distance, all we need to do is apply Pythagorean theorem. So let's do that. So Pythagoras theorem is a squared is equal to b squared plus c squared. So and a squared is obviously ab. So what we need to do is 8 squared plus 15 squared, which is 64 plus, I do not know what the square of 15 is, so I will use my calculator. 15 squared is 225 plus 64. And then we just get the square root of the answer, and it gives us 17. So A is equal to 17. I think it said 224 or 225. I'm just going to assume 225, although we can just look. It was 225. All right. So AB is 17, and that is also the distance between A and B is 17. And now we need to find the coordinates of B. So again, this tells us what we need to add to the x of A and to the y of A to get to B. So we can just do that. So the x of B is going to be 10 plus minus 8, which is going to be 10 minus 8, which is 2, and 1 plus 15, which is 16. So B is going to be 2 and 16. All right. 2 and 16. Okay, let's see question or part B. The point C is 4216, which is right there, and CD is 3 times of AB. Find the coordinates of D. So the first thing that we need to do, it's the distance between CD is basically, or rather, what we add to C. So this just tells us, again, the arrow is from C to D, so it's just asking what do we add to C to get to D. Just like here, it was telling us what we add to A to get to B. So what we add to C to get to D is 3 times what we add to A to get to B, which is this. So all we need to do is multiply that by 3, which will give us negative 24 and 45. Okay, and now all we can do is just add that to 42 and 16. So 42 and 16, and 42 minus 24. Let me just use my calculator. 42 minus 24 is 18. So we have 18, and then 45 plus 16 is 55, 61. So D is 18 and 61. It's going to make sure my math is correct. All right. Now they want us to find AD. So again, all we need to do is find out what do we add to A to get to D. To figure that out, what we can do is find the difference between, so this is D, by the way, this is D. We can find the difference between A and D. So if we subtract A from D, we're going to find out what we can add to A to get to D, right? What the difference between the two is. So we already got D, which is 18 and 61. And we need to minus A from that, which is 10 and 1. So what we're left with is 8 and 60. So if we add 8 and 60 to A, we get to D. So let me just write that as 8 and 60. All right. The point E is K16. Find in terms of K the vector AE. So again, we just minus A from E. So E is K16, and then obviously this needs to K minus 10 and 1. So K minus 10, and then 16 minus 1 is just 15. So I could just give the answer right here, since it's not that much mathematics. It's K minus 10 and 15 is vector AE. Given that AED is a straight line, find K. So what this is basically telling us is AE extends AE. If we multiply that by, let's say, an X, it will become AD, because it is a straight line. So if we just extend this line or multiply it by something, the line gets longer and it extends to become AD. So we just need to find that ratio, right? So basically AE multiplied by an X will give us AD, and we already calculated AD before, which was 8 and 60. So all we need to do is find X, and since these would be multiplied separately, we know that 15x is going to give us 60, which means x is going to give us 4, right? So now we know that if AE, so what that tells us is 4 times AE is equal to AD, right? So what we can do for that is just find K now. So K minus 10 multiplied by 4 gives us 8, which means K minus 10 gives us 2, since I divided both sides by 4. K gives us 12 if I add 10 to both sides. So K is equal to 12. Let me just double check my math again. Okay, everything seems correct so far. All right, now we need to find the area of triangle ABE with the area of triangle CDE. So E was K and 16. K and 16, and we found out that K is 12. So that makes it 12 and 16. and B was 2 and 16. B was 2 and 16. Now they're at the same height, so this remains the same. But 12 minus 2 is 10, which means the base of this triangle, this part right here, is 10. So the first triangle, ABE, is half into the height, which was 15. This is this height. We figured it out earlier. And then into the base, which is 10. All right. And now the second half of that equation is the area of triangle CDE. So again, the height we will know from CD or from ED, but we already had CD. CD was 3, so 18 and 61. For the second triangle, we can figure out the height because we know D, and we already have the vector CD. We figured out CD earlier. CD was CD was 3 times AB, so we did 3 times AB right here. So it's 24 and 45, which means the height here was 45. You go 45 up from C to get to B. So that was the height, and then the base is going to be the distance between C and E. So both of them are at 16 and 16. So that doesn't play a factor, but C is 42 and E is and E is 12. So 42 minus 12 gives us 30. So 30 is the base, and 45, let me just double check, 45 is the height. 45 is the height. All right, so we can just get rid of this half. We can also get rid of this. Yeah, we can also get rid of this because this is a 1 and this is a 3. And then this is also a 1 and then this is also a 3. So what this is basically is just 1 over 3 into 1 over 3, which makes 1 over 9. And that is what the ratio of ABE over CDE, or the area of ABE over CDE, is. Okay, question 6. In 2000, the cost of a packet of nails was $4.20. In 2001, the price increased to $4.50. Calculate the percentage increase. So the percentage increase for price is just the change in price over the original price, right? I don't think I spelled original correctly, but that's okay. Over the original price into 100, since it's a percentage. So the change in the price would be the new price minus the old price. That gives us the change. And then that over the old price into 100. So this is just 0.3 over 4.2 and into 100, and we can just use our calculator to quickly do that. So we can also just do so 0.3 over 4.2 into 100. That gives us an increase of 7.14%. So 7.14%. All right. A new cereal packet contains 20% more than the old packet. The new packet contains, so this is the new, contains 264 grams of cereal. Calculate the mass of cereal in one of the old packets. So this number, so let's say the original packet was X grams. This number is 1.2 because it's 1 of X and then 20% added of X. X is equal to 264 grams, right? And now we can divide both sides by 1.2 to find one of the old ones. So 264 divided by 1.2 means that the old one has 220. So 220 grams in the old one. This was a percentage. All right. Part 3. The builder bought a large number of bags of cement. As a result, he was given a discount of 7%. The discount was $910. Calculate how much the builder paid for the cement. So X was the original price, and then he minused 0.07x from X, right? And he got basically 0.07x was basically his discount. So that was 910. So we can use this to get the original price. Get 910 divided by 0.07. That gives us 30. So that was the original price, but we want to know how much the builder actually paid. So he didn't pay the original price, he paid the discounted price. So let's minus 910 from that. And he actually paid 12,090. 12,090 is what he paid. All right, so far so good. Let's get into part B. So on the 1st of May, 1998, William invested $900 for 4 years at 6% per annum simple interest. Calculate the interest he received on his investment. So it's simple interest, which means the interest is only applied, basically the percentage is only applied on the first year, and you just add that percentage for every year. So 6% of 900 is just going to be 0.06 into 900, and that would be 0.06 into 900. 6% of 900 is 54, and if we multiply that by 4 years, we get 216. So I'm just going to remember that. So 1 year was 54, and 4 years was 216. So calculate the interest he received. He received $216 of interest over 4 years. All right, and this was also a dollar amount. He invested another 900 for 2 years at 6%, another then 900 for 2 years at 6%, and then finally 900 for 1 year. So this is adding to the original, right? So that goes for 4 years, that goes for 3 years, that goes for 2 years, and that goes for 1 year. So the first thing that we have, well, it says calculate the total sum that he withdrew after everything. So 900 into 4, because that's just the money that he starts off with. So 3,600, right? Plus, so he has the 216, which he got after 4 years. He also gets, and 1 year is 54, so the last one, this one, is going to be 54, because this one is only for 1 year. This is going to be 54 times 2, which is 108. And then this one is going to be 54 times 3, which is 108 plus 54. I can just use a calculator for that. So let's just do 54 times 3, which is 162. 162. So this would be all the interests that got added to this original amount. So let's just do that math real quick with our calculator. So 3,600 plus 216 plus 54 plus 108 plus 162. That is 4,140. So this is 4,140 is the total dollar amount that he withdrew. All right, let's move on to question number 7. So a trader bought some paraffin for $500 and he paid X dollars for each liter of paraffin. So in total he paid $500, and the paraffin was actually worth X dollars per liter, basically per per liter, right? Okay, and A part is find in terms of X an expression for the number of liters he bought. So we want to find, if we want to find how this $500, like how he came to that price of $500. So whatever amount of liters he bought, if we multiply that by the price of liters, that's how we got to 500. Since X is the price for 1 liter, multiply that by the number of liters, and we got his price of $500. So to get the number of liters, we can just divide by both sides by X. So 500 divided by X, which would give us the exact number of liters that he bought. So the expression would be 500 over X. All right, part B says, due to a leak, he lost 3 liters of paraffin. So he got this much, and then it leaked away 3 liters. Okay, he sold the remainder of the paraffin for $1 per liter more than he paid for. So he sold it for X plus $1 per liter. All right, write down in terms for the sum of money he received. So he sold this much liters. So going back to our original equation, if we wanted to find out the full price of something, multiply the liters by the price. So this is the number of liters, and then he sold it for X plus 1 liter. So the number of liters sold for X plus $1 per liter would be an expression for the sum of money that he received. All right, he made a profit of $20. Write down an equation in X to represent this information and show that it reduces to 3x squared plus 23x minus 500 equals 0. So this part that we just calculated is the money that he received, which can also be called his revenue. This is how much money he made, right? So this is how much money he made. But what they want us to calculate is the profit. So what profit actually is profit is equal to revenue minus the cost. So it's what he made minus what he actually paid. And we know that the cost is actually 500 because that's what he initially paid. So, and his profit is 20. So 20 is equal to 500 over X minus 3, X plus 1, this is his revenue, and then minus the cost, which was 500. All right, now we can simplify this. So first, let's just multiply it out so we can get rid of the parentheses. So this is going to become, if I multiply X by this is going to become 500 minus 3X, right? And then plus 500 over X minus 3. All right, minus 500. So this 500 goes away and this 500 goes away. All right, now we have minus 3x plus 500 over x, and then if I add 20 to both sides, this would become plus 17. Sorry, not minus 17. If I add 20 to both sides, this would become plus 17. Wait, no, I'm not adding 20 to both sides. I'm subtracting 20 to both sides because I need to make 0. So 20 minus 20 is 0, and minus 3 minus 20 is minus 23. Okay, the last thing I need to do is get rid of this x, so I can multiply the whole thing over here by x and multiply 0 by x as well, but 0 by x is still 0. So this would be minus 3x squared plus 500 minus 23x, and then I can also multiply the whole equation by minus 1. Do the same thing on this side. It still gives a 0 over there, but here it just flips the signs of everything, so this becomes 3x squared plus 23x minus 500. And I think that is what they wanted us to show. All right, so solve the equation giving both answers correct to 1 decimal place. So I've told you about middle term breaking, which is when we break this term to basically have 2 terms that add to make this term but then are multiplied to make that term. However, these are very big numbers to do that with. So another thing we can use is the quadratic formula, which is minus b plus minus under root b squared minus 4ac over 2a. Now let me tell you what all of this means. So this is a, b, and c refer to the coefficients of x. So the coefficient of x squared is a, coefficient of x is b, and the coefficient of x, essentially 0, is this is x2, this is x1, and this is x0, right? Coefficient of x0 is c, or the phrase, the term without the x. So once we have that, we can use that, and these two basically mean that we can take both the positive answer of this, but then also we can take a negative version of that answer, because if we square root anything, we get two answers. So just like minus b plus whatever this gives us, and minus b minus whatever that gives us. All right, so let's set up these equations. So minus 23 plus 23 squared minus 4, 3, and 500, or negative 500, and over 2 into 3. All right, so x would then be equal to, can obviously use our calculator for this. So let's just set that up. Negative 23. Let's try to look at these. Negative 23 plus the square root of 23 squared minus 4 times 3 times negative 500 over 2 times 3. Okay, so the first answer of this x is 9.63. Yeah, 9.63. So 9.63, and the second answer is, all we need to do is change this plus into a minus. So 23 minus, this is negative 17.3. So negative 17.3, right? And I think getting both answers correct to one decimal place, so this would just become 9.6. This would just become 9.6, and this would stay as negative 17.3. All right. Find correct to the nearest whole numbers how many liters of paraffin he actually sold. Okay, so we have a value for x, and then we need to just find essentially this, which was the liters of paraffin that he had that he was selling. So this was the liters of paraffin that he was selling after, he lost the 3, and he obviously couldn't sell those 3 that he lost. So this is what we need to find. And now that we have a value for x, now we have 2 values for x. However, because x is, a number of dollars, unless he's in debt, we don't take the negative value. So I can just take a 9.6 as the value of x, since we need a positive value here, since we need a positive number of liters. So 9.6 minus 3, and again, we can just use our calculator to do 500 over 9.6 minus 3. And that gives us 49.1 if we're doing to one decimal place. However, I think it said find correct to the nearest whole number the liters he sold. So the whole number is basically going to be 49. That is done. Okay, question number 8. Diagram shows 4 points A, B, C, and D on a piece of horizontal land. It is given that AB is 45 meters, AD is 25, and BD is 28. Calculate angle ADB, so this angle. So for this, since we don't have any other angles, what we can use is something we learned earlier called cosine rule. Cosine rule, which if we call these A, B, and C, it basically tells us that C squared is equal to A squared plus B squared minus 2AB cosine of theta, which this angle would be theta. And this is basically Pythagorean theorem, but this is a 90 in Pythagorean theorem, which makes this whole thing 0. And so you get c squared is equal to a squared plus b squared. But if you write it in the cosine form, then yeah, this is what this is. But anyways, so we know that c squared would be 45 squared is equal to 25 squared plus 28 squared minus 2 into 25 into 28 cos of the angle we're trying to figure out. All right, so let's just simply use our calculator for a lot of these. So 45 squared, and I'm just going to minus from this 25 squared plus 28 squared, since that's the first thing we were going to do anyway. So that gives us 616. So 616 is equal to, let's also make this a full number. So let's do 2 into 25 into 28. That gives us 1400. 616 is equal to 1400 cosine of theta. All right, so that means cos of theta is equal to 616 divided by 1400, 11 over 25, or 0.44, and then we can just do cos inverse of answer. So this was 0.44, and then theta is equal to 63.9. 63.9 degrees. 63.9 degrees. All right. So let's get rid of our numbers here. I'll just write the answer here, which was 63.9. That does not look correct. So I did make a mistake here, actually. Thing is that cos was actually negative. So cos was actually negative here, which means that to turn this into a positive number, this was obviously, the negative cos is obviously 0.44, but that would mean that cos inverse of cos of theta would actually be negative, let me write that again, negative 0.44, and the answer we would get would actually be cos inverse of negative 0.44, and that would give us 116.1. So what we actually wanted was theta is equal to 116.1. Because why I realized it was negative, because the answer we got was less than 90 degrees, right? So it would have been like something like this, right? That's what the angle would be. And obviously this doesn't say it's drawn to scale, but even then, if it feels wrong, be sure to double check. But anyways, we have 116.1. So 116.1. Also, given also that CD is equal to 22 meters and that angle ACD is equal to 33 degrees, calculate ADC. So we want to now calculate this one. So in order to calculate this angle, we can first actually calculate that angle. We can't use cosine rule here since we don't actually know what this is, but we can use something else we've learned, which is the sine rule or the sine law. So the sine rule says that the opposite length and the sine of the angle, so 25 over sine of 33 is going to be equal to 22, which is the opposite length and the sine of the angle. So I'm going to call this x, actually, since this one I'm going to call theta. That's what we want to ultimately get, is equal to the sine of x. So we can very quickly just figure this out. So what we do here is 25 over the sine of 33. All right. And then we want to do 22 divided by the answer. So we get that, and then we can simply do the sine inverse of that answer to get 28.6. So this would be 28.6. And now, since we know that all the internal angles of the triangle add up to 180, we can minus 33 plus 28.6 from 180 to get theta, which is going to be 180 minus 33 plus the answer that we got last time. That gives us 118.4. So theta is going to be 118.4. 118.4 degrees, and let me also note that down over here. So this is 118.4 degrees. All right. The line BD is produced beyond D. Calculate the shortest distance from C to this extended line. So they're saying that this line is extended, and now they want to find the shortest distance from C. So the shortest distance usually most accurately means the perpendicular distance, because the distance is usually the shortest here. If I extend it here, this line gets longer. If I extend it here, this line gets longer. But if I keep it perpendicular, the line remains the same. Right, so we know one of the angles there is going to be 90, but we don't know the other angles, right? But we do know that this whole part is 118, and then we can find out this part because we know 116. And if this line goes straight, this whole thing is going to be 180 since it's a whole straight line, right? So 116 plus whatever this is, I'm going to call this y, is equal to 180, right? And then this is going to be theta, which we need again. So let's do 180 minus 116.1. And I'll use my calculator again. 180 minus 116.1. gives us 63.9. So y is equal to 63.9, and that way theta is going to be equal to what we got last time, which is 118.4 minus y. So let's just use our calculator again. So 118.4 minus the answer, which was y, and that gives us theta to be 54.5. So theta is going to be 54.5. So now we basically have a triangle that looks like this, right? Looks like this. And this angle is 54.5, and this angle is 90. And all we want, and also this is 22, this length, and we want to find this length, which I'll call x. So all we can simply do is use, well, we have SOHCAHTOA, right? We have SOHCAHTOA. And so what do we have here? We have, if we use this angle, we have opposite over, we do have the opposite and the hypotenuse. We don't have an adjacent, but we have an hypotenuse. And if we use tan, we have opposite, we don't have an adjacent. So let's use tan, I guess. Or sorry, sine, right? So the sine of 54.5 is going to be equal to the opposite, which is x, which is what we're trying to find out, over the hypotenuse, which is 22. So all we need to find x is 22 sine 54.5. That is going to be, with our calculator, 22 sine 54.5 It's going to be 17.9. You can also write 18, but I will write 17.9. X is equal to 17.9, and we're not rounding that off. The shortest distance is 17.9. All right, finally, D is the foot of a vertical mast, dt. The angle of elevation from the top of mast dt from the top of mast T from A is 40. Calculate the angle of elevation. So essentially, in the third dimension from D, they've placed a mast on D. So D, they're still like horizontally, D still goes to A and D still goes to B like this, but now there's a mast going up from D. So imagine if you put a pencil coming out of the page right here, you can imagine that is what T would look like, but we're drawing it in 2 dimensions. So this would still be 25 because this is D, this is A, and this is B, and now this is T instead of C, right? So 25, 28, 25 and 28. And the other thing they've told us is the angle of elevation from A to T is 40, and we want to find the angle of elevation from B to T. So we want to find this, which again, I'm just going to call theta. All right, so what we can do is, so again, we can again use SOHCAHTOA, right, to basically first find dt. So here we don't have an opposite, we don't have a hypotenuse. So we don't have an opposite, we don't have an hypotenuse, right? I wrote SOHCAHTOA, but it's actually SOHCAHTOA, right? What we're trying to find is the opposite. So all we're left with is we need to find the opposite, and we have the adjacent. So, and we have the angle. So tan of 40 is going to be equal to the opposite. I'm going to call it x again, x over the adjacent, which is 25, and that means that x would just be equal to 25 tan of 40. So let's find that out again. 25 tan 40 gives us 20.977. That's what I'm going to take that as. So 20.977, just for accuracy, right? So now we have this, and we have this, and we just need the angle. So again, we have the opposite, we have the adjacent, but this time we don't have theta. So tan of theta is equal to 20.977 or 28, and we can just do the tan inverse of that. So tan inverse of 20.977 divided by 28 gives us 36.8. So this is equal to 36.8. And that is the angle of elevation. So they're not 38, 36, 36.8 degrees. Everything seems correct, but I will double check. And yeah, I think everything's correct. So that was question number 8. Okay, we're on question 9. So the value of pi is supposed to be taken as this, and the area of a curved surface of a cone of radius r and slant height is pi rl. The volume of a cone is 1/3 the base area into the height. So they don't expect you to memorize the area and the volume of a cone, is what I'm learning here. But there are other areas of volumes that you should know. Anyways, diagram 1 shows a traditional hut with, so this is diagram 1, right? Diagram 1 shows a traditional hut which consists of a circular cylinder with an overhanging roof. The roof is curved. The roof is the curved surface of a cone, and it's supposed to be a central vertical pole. Diagram 2 shows a vertical cross-section of the hut, BE and CD are horizontal. So it shows a vertical cross section. Basically, they like cut it in half, like with a knife on the middle, and this is what you see on both sides. All right, and BE, so BE and CD are exactly like horizontal and straight. And AN is equal to 4, which is shown here. BM is equal to ME, which is equal to 3.6, and BC is equal to DE, which is equal to 1.3. Show that AB. So we want to show that this AB is equal to 4.5. So they want us to show that this is equal to 4.5 firstly. So the first thing that we can do is we can find out what this part is. We can find out what this part is, and then we can simply use Pythagorean theorem. So how we're going to find that out? Well, it's pretty simple. We know what the whole thing is, and we know what this part is. So we can just take 4.0 and minus 1.3, so that would leave us with 2.7. So we know that this is 2.7, and now we can just do c squared is equal to a squared plus b squared, which is Pythagorean theorem. C squared is equal to 3.6 squared plus 2.7 squared. And let's use our calculator to figure that out. So 3.6 squared plus 2.7 squared. And then, so that gives us 20.25, and then we can get the square root. That's the cube root. We want to get the square root of the answer, which gives us a 4.5. So C equals 4.5, and that is what we need to show, right? 4.5, all right. Calculate the volume of the inside of the hut. So when they're saying inside, I think they only want the volume of this area, because this part is not inside of the hut. Right, so we want the volume of this plus the volume of that. So first, let's do the part that we know, which is the volume of the cylinder, which is just base area into height. So the base area is going to be, well, it's going to be pi r squared, because it's just a circle at the bottom. Like the bottom is just a circle. So pi r squared, which they gave us a value for pi. I should probably note that down somewhere here so that it's easier to reach. So not 1. It is 3.142 is what they want us to use as pi, and the radius is 3.6. Radius is half the diameter. So this is just going to be 3.142 into 3.6 squared into, and then base area into the height of the cylinder, which is 1.3 for this part, since this cylindrical part. So into 1.3, and we can just use our calculator again. So 3.142 into 3.6 squared into 1.3. That gives us 52.9, so 52.93 or 94. So cylinder volume is equal to 52.94. That's what I'm going to take. And then we want the volume of the cone area. So we have pi RL basically, or sorry, that's the surface area. We want the volume. So volume is equal to 1/3 of the base area into the height. So here the height is 2.7. Nothing else actually changes. Nothing else actually changes. So again, the base area is pi r squared is the base area. We're doing a 1/3 into that, and we are doing the height, which is 2.7. And the height, which is 2.7. So let's write that out again. So 1/3 into 3.142, 3.6 squared into 2.7. 2.7. And we can do that all in our calculator again. We can do 1 over 3 into 3.142 into 3.6 squared into 2.7. So that gives us 36.65. So cone volume is equal to 36.65, and we can add both of these together. 36.65 plus 52.94 gives us 89.6. So full volume is going to be 89.6. That is the total volume of the hut, 89.6. I think we can say meter cubed. Okay, the second part they want us to check is the total, or they want us to calculate, is the total surface area of the inside. So now they want the surface area. So we want the curved surface area of a cone of radius r. So we want curved surface area, so we want 3.142 into 2.6 into 2.7, right? That's the first curved surface area. Then we want the curved surface area of the cylinder, which is 2 pi RL, right, or 2 pi RH. And here our height is 1.3, so we want 3.142 into 3.6 into 1.3. And lastly, we want the bottom area, which is pi r squared, so which is just 3.142 into 3.6 squared. So let us do all of these individually. Okay, so I noticed a mistake I'm making, which is I forgot that this said slant height and not the normal height. So this is the slant height. So what I actually need to do here is not have 2.7, but have 4.5. So that would be a completely different number. It's going to be 3.142 into 3.6 into 4.5. It's going to be 50.9. So this is going to be 50.9. And now we can easily just 50.9 plus 29.41 plus 40.7. That gives us 121.01, or we can just type that as 121. So that gives us 121 meters squared. Okay, part C says the sun is directly overhead. The shadow of the overhanging section of the roof on the ground is a circular ring around the hut. So there's a circular ring around the hut based on the sun being overhead, right? You can kind of draw it here. So there's just a circular ring around this, and it's obviously like it'd be colored black because the sun is shining from up here, right? And we can give the sun a happy face. So AP, shadow of the hut, okay, AP is equal to AQ, which is equal to 5.5. Calculate PQ. So AP is equal to AQ, which is equal to 5.5. So they're saying that this is equal to 5.5, and this is also equal to 5.5. And they want us to calculate PQ. They want us to calculate that. So what we can probably do for this is we can just calculate like one side, because I know that these angles will be the same, right? These angles will be the same. So we can just figure out this angle somehow, which I'm going to call theta. Figure out theta somehow, which is going to be the same as that, and that would allow us to basically calculate the opposite end. All right, so what we can probably use for theta is we want to find the opposite. We have the adjacent, so and we have theta. Well, we have the opposite and we have the adjacent. We don't have theta, so we can use TOA or tan. So tan of theta is equal to 2.7 opposite over 3.6, and that means theta would be equal to tan inverse of 2.7, although it'd be the same as 27 over 36. I'm going to do it exact. All right, and that is 36.9. Or 36.87 is what I'll take. 36.87. All right. Now we want to find out PQ. Okay, now we want to find out PQ. I'm just going to draw it over here just so it's easier, right? So we got 36.87 here, and we got 36.87 here. This is Q, this is P, this is A, and we know that the slant heights are 5.5 is what we've been told, and we basically want to find out the height of the middle. So obviously this will be angle, so we have the hypotenuse, and we want to find the opposite. So again, let's look at SOHCAHTOA. So TOA. So we don't have the adjacent. So the only one we can use is sine. So the sine of 36.87 is going to be equal to the opposite, which let's call it x. That is what we're trying to find, right? No, that's not what we're trying to find. We're trying to find this. We're trying to find this. Apologies, yeah, we're trying to find PQ. So we don't need to use SOHCAHTOA, or we don't need to use sine, rather. So let me figure that out again, right? So we just want to find x, and these will be the same, so we'll just multiply it. So we actually have, so we'll actually use cos, because cos of 36.87 is going to be equal to x, which is our adjacent, over the hypotenuse, which is 5.5. So this is going to be 5.5 cosine of 36.87, which, let's figure that out. So 5.5 into the cosine of 36.87, which gives us 4.39999, and because there's two of them, let's multiply that by 2, and we get 8.79. We can type that as 8.80. So do 8.80, right? Okay, now they want the area of the circular ring. Want the area of the circular ring of the shadow outside the hut. So they only want this area that is outside the hut. So all that's going to be is the overall area of the shadow, including the hut, minus whatever's inside. So it will be what we just got, the radius that we just got. We just figured out the diameter, which is PQ. So the radius of that would be the half of that, which is 4.4. So 3.142 into 4.4 squared. So give us the entire area, including the hut, and then minus that from 3.142 into 3.6 squared, which was the area of the inside of the hut. And that should give us our answer. So let's do 3.142 multiplied by 4.4 squared minus 3.6 squared. And that gives us 20.1. And so the area of the circular shadow outside the hut, ignoring the walls, is 20.1 meters squared. And this was meters, and that it took a while, but that was question number 9. All right, let's do question number 10. So I do want to say this question involves graphing, which means my answers may not be 100% accurate because it's very hard to draw curves on this, especially if you're trying to connect some points. It's kind of relatively pretty difficult to do that. See, even then I missed a curve. So my answers might not be 100% accurate, but you'll figure out how to actually do the question either way. And it might be just off by like 0.1 or like 0.01 for the most part. Anyways, let's do this question. So a man stood at the top of a tower. He threw a ball vertically upwards. The height h meters of the ball above the top of the tower at a time t seconds after it was thrown is given by this formula. The table below shows some values of t and the corresponding values of h. So the height at whatever seconds, correct to 1 decimal place. Explain the significance of the value of h minus h. So the height is negative 12.5 when t is 5. So they told us that he's standing on top of a tower, right? The man is here, and then he throws a ball. It goes up, but then it goes down. And if we assume that the man is at 0, that means when it's below, like when it's 12 meters below that, it's going to be actually minus 12. So the ball is below the starting position, and that's why it's negative, right? Because the starting position was 0, and then it wants us to find the value of p. So p happens at t is equal to 6, so we can just take this equation and put 6 instead of t. So 6 minus 4.9, and then 6 squared is 36. So let me just use my calculator for that. Okay, so 22 into 6 minus 4.9 into 36, right? That is negative 44.4. So negative 44.4 is the value of p. The value of p is negative 44.4 and meters, although we don't have to specify that. All right, so now it wants us to draw a graph using a scale of 2 centimeters to 1 second on the horizontal axis. We have to keep between 0 and 6, and on the 2 centimeters is to 10 meters on the vertical axis, and we have to keep from minus 50 to 30. So helpfully, the paper in the software does actually just do 1 centimeter, so we will just do this and this, and we'll mark the axes. So every 2 centimeter is equal to 1 centimeter, so this is 0, or 1 second. This is 1, 2, 3, 4, 5, and I got that perfect, 6. And then on the opposite hand, it is, so this is, it goes from 0, and then every 2 is 1, so this is 10, 20, 30, and that's as high as it wants us to go, so that is 30 there, right? And on the bottom one, it is minus 10, minus 20, minus 30, minus 40, and it wants us to go one more, so extend it a little further to make sure we can get -50. All right. On your axis, plot the points given in the table and join them with a smooth curve. So my curve is probably not going to end up very smooth, but either way, there's a point there. So, and also like when you're doing this on actual graph paper, you're going to have like very small squares, so you'd be able to do this a lot more accurately than I am. But anyways, so at 1 second, it is at like 17.1, so that's going to be like somewhere here. It is at 2 seconds, it's at 24.4, which is going to be around here. Then 2.5 is still at 24.4, so it's going to be at the same point. Then 3 is at 21.9, it's going to be roughly here. 4 is at 9.6. So that's going to be like here. 5 is at -12. That's going to be around here. And then 6 was at -44.4. So it was like around here, 44.4. Now this might take me a few tries, so there might be a cut. Okay, I think that's the best I can do. Obviously, it's not that great, but it might still be able to help us out. The greatest height of the ball, so use your graph to find the greatest height of the ball above the tower. So for me, that's going to be a little bit like around here. And that I'm going to say is probably, so if I take this, right, and let me just make my line a little thinner as well. If I take this, it's like 25, but I'm going to take more like 24.5 or even 24.8. I'll just do 24.8 just to be safe. Just so I know the error might be a little bit, but I think that should be in a good range. We might even do 25. I'll do 24.8 for now. All right, the second is the length of time for which the ball was more than 20 meters above the top of the tower. So the length of time for which the ball was more than 20 meters, so here to roughly here. So I'm going to say that is about 1.25. So from 1.25 to roughly 3. I would say 125. Right. So let's do 3.125 and like 1.25. So 1.875 is how long it was above 20 meters. We'll just do 1.875. Again, these would be estimates based on my graph, so if you have a more accurate graph, your answers would be more accurate. Anyways, let's do, by drawing a tangent, find the gradient of the graph at 4 and 9.6. So if my line actually touched that, we would be drawing a graph somewhere here, but let's do that anyway. So if the tangent was like there, right? Yeah, maybe I draw the tangent a little bit that, perhaps. I think it would be more like this, because it just needs to, so a tangent just needs to touch the one point that you want it to touch. I think that's a good tangent because it also gives us a very good value over here. So our first value is obviously 4 and 9.6, and our second value that we're going to get is going to be, we're going to take 25, so we're going to take 3 and 25, and so we can do 9.6 minus 25, not 20, 25 over 4 minus 3, and so 9.6 minus 25 is negative 15.4, so negative 15.4, we can just apply it there. Explain your answer to EI. Tell us what tells you about the motion of the ball. So it's because it's negative, which means the ball is going downwards, right? So the ball is going downwards. All right. The ball hit the ground at 5.4 seconds after it was thrown. Use your graph to find the height of the tower. So 5.4 would be like here, and then that would essentially tell us how tall the tower was from whence it was being thrown. So I'm just gonna maybe, so it's at like an exact 20, but I'm gonna write 21 just to be safe. Possibly if it was like going straight, right? Let's write 19 meters just to be safe. Obviously, on an actual graph paper, we would have much more accurate answers, but that is how you would do that. You would use the graph a lot in this question. But that's question 10. Okay, last question of the day. So a bag contains 5 balls numbered 1 through 5, and another bag contains 6 balls numbered 1 through 6. One ball is drawn at random from each bag. Find the probability that one ball is numbered 1 and the other is numbered 6. So for the first one, we want 1 is numbered 1 over 5 possibilities, and from the other one, we want another 1, but it's numbered 6 out of 6 probabilities. But what goes in the middle? So one way I like to remember this is the little thing called op-amp, which basically tells me that if it's or, I plus, if it's and, I multiply, right? And there's some differences. Obviously, this doesn't always work because with probability, you have something called mutually exclusive and so on. So in places where it's like mutually exclusive or not exclusive, this may work or may not work. It depends on the question. So I'll probably have a video on probability out at some point, and that would go deeper into this. But for most questions, you can probably apply this and get through the question. So if it's an or, you plus. If it's an and, you multiply. So for this, we want to draw 1 out of 5 and 1 out of 6, and that gives us 1 over 30 for drawing both of those. So that is part 1. All right, part 2, we have both balls have an odd number. So for the first one, the odd chances are 3 over 5, and 3 over 6. 3 over 6, which gives us 9 over 30, which gives us 3 over 10. All right, third part is both balls have the same number. So for this one, it doesn't matter what you draw from the first part, right? It doesn't really matter what you draw from the first part. Since the first part can be 5 over 5, it's what you draw from the second one which matters. So so whatever you drew here, there's only a 1 out of 6 chance of drawing the same one. So this is just going to be 1 multiplied by 1 over 6, which is just 1 over 6. All right, and now for the fourth part, we have the sum of the numbers on the balls is 9. So the sum of the numbers on the balls is 9, which means, so we can either do 4 over 5, 4 and 5, that'll make 9, or we can do 3, 6, that'll make 9, so the first one is 3, or we can do 5 and 4, that'll make 9. And we can't do 3 and 6 the opposite way because there's no 6 in the first bag. So this is 1 over 5 and 1 over 6. This is also 1 over 5 and 1 over 6. And then this is also 1 over 5 and 1 over 6. So these are all 1 over 30. They're all 1 over 30. 1 over 30, 1 over 30, but all of these also have an or, so it's either this or this or this, and when we have an or, we plus. So this or this or this, and this will give us 3 over 30, which will give us 1 over 10. And that is that first part. Now for the second part, at a school, 300 pupils took an English test. The table shown below is the cumulative frequency of their scores. Using a scale of 2 centimeters to represent 10 marks, draw a horizontal axis from 0 to 60. Using a scale of 2 centimeters to represent 50 pupils, draw a vertical axis of 0 to 100. So I went and I drew this already because I had to work really hard to do this. And I'm just going to use this one. But for the most part, make sure the axes are correct. Make sure you're labeling your axes. And yeah, yours will probably be much more accurate than mine since it would be on actual graph paper. But we may be able to figure out how to actually do this with this, even though my answers might not be 100% accurate for this one. So use your graph to find the lower quartile score. So the lower quartile would be 1 over 4 into the number of pupils, right? Which should be 75, I think, but let's also calculate that. So 1 divided by 4 into 300 is 75. So, so the lower quartile score, so 75 pupils get the lower quartile score, and I think so 25, 50, so it would be like this, and that is roughly, let me make this proper. So that is roughly, for me on my graph, it is a score of about 3.2 or 32 rather. So 32 would be Q1 or lower quartile. So lower quartile would be 32. Interquartile just means Q3, so quarter 3 minus quarter 1. So we already know quarter 1, which is 32. And now for quarter 3, we can do the same thing. We can do 3 over 4 into 300. So let's just do that. So 3 over 4 into 300. That gives us 225. So 225. So 225 pupils lie at this score, or rather less than or equal to 225. So again, this would be like here, and that gives me roughly, I think, a 47. So I think 47. So 47 minus 32 is, I think it's 15, but I will use my calculator just to make sure. So 47 minus 32 is 15. So that is our interquartile range is 15. Okay, so given that 70% of the pupils pass the test, use your graph to find the passing mark. So 70% of the pupils have to be above whatever number of pupils we get that pass the test. So let's do, so 7 over 10 into 300, which is just going to be 7 into 30. 7 3s are 21, so that's just going to be 210. And again, I can use the calculator as well to figure that out. So 0.7 into 300 is going to give me 210. Okay, so 210 pupils need to be above the line. So actually, we want to do 300 minus 210 and 90. So 90 is where the line is. 90 would be below that. They didn't pass. And the people above that will be the ones that passed. So I think so 75, 75, 80, 85. So I think 90 would be roughly here, around here. Again, using an actual graph paper, much better. And I think this would be about like 33.5 or 34. I would call this probably 34. So I think the passing mark would be 34. All right, obviously these won't be 100% accurate, but this is how you would do this question. Your numbers would differ based on how accurate your graph is, and also how easily you make your lines and everything. But that was the entire paper. I hope this was helpful. Please subscribe for more, because I will definitely have all the papers coming up and all the really tough and pretty much all of the concepts that you need to do these papers will be uploaded as well. But thank you so much for watching, and I'll see you later. Bye.